Our first presenter today is Kiley Foster. Kiley is an environmental studies major with minors in data science and urban design and planning. And she's been on the Dean list from 2020 to 2024. Pretty cool, huh? Not only that, she will be graduating in June, magna cum laude. You can go ahead and pass it out. Now, lest you think Kiley is just some academic egghead, she's also on the UW climbing team, so that seems pretty cool, right? Yeah. And now she's going to take us to new heights. Thank you, I'm here all night. With a presentation titled Oysters Gone Wild, Exploring Pacific Oyster Naturalization in the Salish Sea. She worked with NOAA's Alaska Fisheries Science Center. Her site supervisor was Jordan Hollersmith, Rebecca Cates, and Henry Fleener. I think they were all at the Juneau lab, so she was working remotely with them. And her faculty advisor on campus was Mark Sherrill from right here in the School of Aquatic and Fisheries Sciences. Let's give her a big welcome as she comes to the program. So you don't need it? Green light?
All good?
All good.
Can you hear me?
Yep. Space.
Awesome. Who here has ever eaten an oyster? If you have, there's a good chance it was a Pacific oyster. Pacific oysters are one of the most cultivated invertebrate species in the world. Ready? Kidding. Pacific oysters were brought over from Japan in the early 20th century to offset the decline of native oyster populations due to overharvesting and habitat degradation. They now play an essential role in our aquaculture industries worldwide, our economies, and our environments. Pacific oysters don't just exist in hatcheries anymore, but in our seas as wild populations. This is naturalization, the process by which a non-native species becomes established and self-sustaining within a new environment. As both an introduced species and an ecosystem engineer, the presence of Pacific oysters has significant influence on the dynamics of the Salish Sea. However, the factors driving the naturalization of these wild populations remains understudied. So for my research, I posed the questions: what environmental factors influence Pacific oyster naturalization in the Salish Sea? And what impacts do they have on the marine ecosystems that they naturalize in? For my internship, I worked with the NOAA Alaska Fisheries Science Center. My work primarily consisted of interviews to establish a ranked list of naturalization factors, which went on to inform the creation of a map that NOAA could use to look for patterns of Pacific oysters in and around Washington. I conducted 15 interviews with oyster experts from federal, state, tribal, and commercial sectors, hailing primarily from Washington, but also BC and California. My takeaways were supplemented by literature on oyster habitats, conservation efforts, and climate change impacts. As I said, a main goal of my interviews was to isolate the top factors driving Pacific oyster naturalization. Sea surface temperature was overwhelmingly identified as the most significant factor, followed by food, predation, habitat, and water retention. I'm going to focus on the first three. Sea surface temperature was highlighted by 94% of interviewees and ranked as the most important factor by 70%, aligning with existing literature indicating the oyster's preferences for warmer waters. Food abundance is the second most common factor identified. Phytoplankton concentrations, as seen in the lighter colored swirls in the water of the image here, play a vital role in supporting the Pacific oyster's health and reproductive success, enhancing their resilience in new environments. Predation and disease are also critical factors. An increase in predators, such as the sea star seen here, or an increase in various viruses, could devastate oyster populations, especially during early life stages. Rising sea temperatures could be advantageous to Pacific oysters, expanding their current range and facilitating naturalization. However, some caution that rapid warming could have adverse effects on food sources and vulnerability, adding complexity to the relationship between climate change and naturalization. Understanding naturalization trends is crucial as we work to assess the impacts that Pacific oysters have on native ecosystems. Pacific oysters can be really beneficial for local environments. Each oyster can filter up to 50 gallons of water a day, with a majority of interviewed experts agreeing that this enhances ecosystem quality. Pacific oysters also alter the habitat around them just through their physical structure. The hard substrate of their shells form reefs, creating new habitat for some creatures to live in, but also potentially crowding out others. There is worry that Pacific oysters could outcompete native Olympia oysters, as both food and space may be limited. 80% of interviewees cited potential conflicts between the introduced and native species. Pacifics are larger, grow faster, and are already well established in the Salish Sea. These interspecies dynamics are complex, and the relationship between the two requires more study. However, there is a possibility that Pacific oysters could dominate the Salish Sea over native ones. Managing a non-native cultivated species requires walking a fine line. Next steps include continued research on naturalization impacts and collaboration between scientists, policymakers, and stakeholders, as well as integration of Pacific oysters into marine management plans. It's also essential to prioritize the protection and restoration of native oysters, ensuring that the benefits of Pacific oysters do not outweigh the marine biodiversity and native species. Just as the Pacific oyster has made its mark on the Salish Sea, this work aims to leave its own imprint on our understanding of naturalization. Next time you eat an oyster, remember the intricate ecological balance needed for a sustainable future where our economies, ecosystems, and taste buds thrive together. I would like to thank my site supervisors at NOAA, my faculty advisor, everyone who let me interview them, my POE cohort, and my friends and family for making this possible. Thank you. I'm gonna put this in.
Question?
Yeah.
Like you talked about heat as a factor of climate change. I'm curious about like acidification, you know, that like that shell production for a lot of species.
Yeah.
I'm wondering if
Yeah, so the question was about ocean acidification and how that affects Pacific oysters. So that wasn't my main area of focus, but I know that that is a big factor, and Pacific oysters are fairly vulnerable to ocean acidification for the reason you mentioned, like their shells don't grow as well. So that is a really important factor to think about when looking at climate change in Pacific oysters. Thank you.
you mentioned that the oysters were introduced. I was wondering if they're considered like
The question was, I talked about the species being introduced or non-native. Are they considered invasive? So I did not call them invasive very specifically because that is a more loaded political term. It has a negative connotation to it. So some people do consider Pacific oysters to be invasive. However, pretty much everyone I talk to and my site supervisors do not, because of the environmental impacts they do that are well known are pretty beneficial, and the negative impacts are not as well known or studied. Thank you. Yeah, one more.
about oysters and like how close they are to urbanization, and if you looked at if like pollutants and that the Salish Sea is part of the port, if that had any connotation to just the survival of
Good question. So is our Pacific oysters affected by urbanization and their proximity to like pollution and that kind of stuff? That was not in my research focus, so I'm not totally sure how that may impact Pacific oysters. They are cultivated throughout the Salish Sea and like throughout Washington and have been for a really long time. So clearly it's not the worst, I guess, but I don't really know the answer to that. So I would have to see what that would be. But thank you.